All right, time to move on. Number 11, we're going to determine whether the sequence converges or diverges. So let's see. Number 11. So what do we have? We want to see whether the sequence converges or diverges. So A, 6 to the n times 4 to the minus n, that's equal to 6 over 4 to the n. And so limit as n goes to infinity of 6 over 4 to the n. That's the same thing as limit x goes to infinity as a function. 6 over 4 to the x. Again, you wouldn't have to do this in this much detail, but just so we're clear, this is a function that agrees at every value of n. And we know as x goes to infinity, this is an exponential function. The base is bigger than 1. So this limit is equal to infinity. So the sequence does not converge. Okay, so part B gives you an is equal to n over the square root of n cubed plus 3. So limit as n goes to infinity of n over square root n plus 3 is equal to, let's do a little bit of work, n goes to infinity, n over n square root n cubed, 1 plus 3 over n cubed. You might recognize this calculus trick. And now this is limit n goes to infinity, n to the 3 halves, square root 1 plus 3 over n squared, cubed. So as n goes to infinity, this guy goes to 0, and we're left with limit as n goes to infinity over n to the 3 halves. So this limit goes to 0. Okay, so that's part B. Next is part C. An is the natural log in parentheses, 2n squared plus 1 minus natural log n squared plus 1. So once again, limit as n goes to infinity of these guys. So I have logs of some things. So this is the limit as n goes to infinity. Natural log 2n squared plus 1 divided by n squared plus 1. This is using the log rules. Log of a minus log of b is log of a over b. And now we've talked about log as a continuous function, so I can put the limit inside. So let's do that. As this goes to infinity, the inside's going to go to 2, so this is natural log of 2. So that says, as n goes to infinity, as n gets really big, this sequence just gets really, really close to 2. And that's it for convergence or divergence of sequence. So let's say converges here, just so we're being explicit. Converges, because it goes to log 2. This converges, because it goes to 0. And this does not converge. So it's enough if it converges. If you find a specific value, that's enough. But for some problems, and especially when we talk about series, you might know that it converges, but not know what it converges to.